Hello everyone. My name is Manolis Chaniotakis, and it is a pleasure to welcome you to this discussion with Dr. Isabelle Cordero Carrion. The discussion takes place in the framework of the series of talks by famous female scientists organized by the PICO EU project. So, let me say a couple of words, and then, Isabelle, the floor is yours. Isabelle Cordero Carrion is a professor in the Faculty of Mathematics of the University of Valencia in the area of applied mathematics. She finished her mathematics degree and the PhD in computational astrophysics, both in the University of Valencia. She works on developing numerical methods for solving partial differential equations in numerical relativity and gravitational waves, and since 2016, she is a member of the Virgo collaboration. Isa, welcome to this discussion. It's a pleasure to have you.
It's my pleasure. It's really nice to be part of this wonderful project. And I say thank you to everyone working in this project and welcoming me to participate a little.
Thank you, Isa. So, could you tell us a couple of things about yourself first?
Yeah. So, well, in addition to what you mentioned, thank you very much for this introduction. One of the things scientists do is working a lot and traveling a lot. So actually, after my PhD in Valencia, I went to the Max Planck Institute for Astrophysics in Garching. It's very close to Munich in Germany. And I was Alexander von Humboldt Fellow, so I am really happy about this fellowship. Also, I went afterwards to Paris in the Observatory of Paris Meudon. It's very close to Paris and in France. And then I also have been visiting a lot of institutions all around the world, in all the continents, so we really travel a lot. In particular, I am very, very proud and very, very happy that I got the Simons Eminator Fellowship of the Perimeter Institute in Canada in 2019. It's a fellow for women in physics and mathematics, and it allows you to go with your family and some of your collaborators to a research stay of a few months in the perimeter, and it was really nice experience. As you know, I really love outreach and dissemination of science, so I try to participate and be active in outreach activities, but I am a very normal person, so I love dancing, I love music, and I am fully committed to the fact that everyone should have the same opportunities, should have access to science, in particular girls. And we are very close to 11 February Day, so I am really happy to be here.
Thank you, Isa. So, let me start by asking you a question. Can you remember the moment or the experience that made you fall in love with science? What did it feel like, or who or what helped spark this interest?
Okay, so I think I had like two moments. The first moment was about maths because I really started doing maths and not physics. And if you ask me, do you think you want to be mathematician from the childhood? No. I was thinking about playing soccer, go out with my friends, and this kind of things. But I remember as a like continuous thing that if someone told me, Isa, you have to do this, I say, why? So I was not doing the things even from my parents, that was a little annoying for them, because they were like telling me to. It's like, give me an argument. If you give me a good reason, okay. So for example, Isa, you have to clean your room. No, why? Well, because I cannot clean the whole house. Okay, that's a good reason. I will clean my room. No, these kind of things were, and I was not too aware until I really started the high school and say, this is called maths. When you give an argument, this is called maths. And I really love this way of working and of thinking. So I discovered like, oh, that was really what I had in mind since the very beginning. And that's why I wanted to go to maths. And then I started to study so weird things, but so amazing things. I was very happy. And at some point, I discovered that really a lot of tools that we were using in mathematics had examples in physics. Like the very same universe. The very same universe is geometry. So that was like the second moment, like, oh my God, all these wonderful tools are just the way we really use to, the way we understand the universe as a whole, and also the weird places, the most weird places that you can imagine, like black holes, no? So these two moments, like reasoning and arguments, are the way I really want to follow, to life, to live, to do everything in my life. Something was like, oh, but all this physics is nothing else than applying mathematics in a way, no? Geometry, numerics, algebra, everything can be viewed like space-time, black holes, particles, and this was like the point. It made me like explode, no? So that's why I moved from Malaga to Valencia. I started mathematics in Malaga, where I am from, and then I moved to Valencia because it was there was a natural way of going from maths to physics. And also I had a lot of family there. My grandmother lived in Valencia, so I moved there to really pursue my dreams, no?
I see. This is very, very interesting. So actually, you started from math as a fundamental knowledge, and then you expanded to physics, right?
So yeah, somehow. It was like finding the real world application, let's say in these ways.
I understand. But as you proceeded with your science and your studies and your career, you must have faced some challenges. So my next question comes to what were some of the biggest challenges you faced as a woman pursuing a career in physics and mathematics, and how did you overcome them?
Okay, I have to say that that was really like progressive, and this depends a lot on the person. I have talked to a lot of women, and it really depends a lot on the person and the environment. But one common thing, and that I also suffer, is that physics is a very competitive environment. Maybe because in mathematics we are few people and we have like so many kind of potential applications. But in physics, it's really challenging. There are a lot of people working very hard and with a lot of talent, and not always we have a lot of financial support. So it's very competitive, and it's very difficult in general to get recognition to your work. But especially in astrophysics and in computational, this is very hard for women. We are ignored more times than other male colleagues. And for example, I remember a talk of a collaborator, and he explicitly wrote the names of all his collaborators in principle, but my name was not there. So it's not like start with something big, but this kind of not giving visibility to your work, not giving visibility to your name, ignoring your work, maybe not in purpose, because maybe you forget one person, no? Of all your collaborators, but normally is the woman that is more ignored than other male colleagues. And there are also a lot of examples. It's not my case, it's not my particular view. There are a lot of examples in the history where the work done by women was not taken into account or even assigned to another male colleague. So this is more like a warning. Think about everyone who contributed, including men and women, because we should not miss the work of anyone. So this is one thing. And then it really depends. During my PhD, I had a wonderful supervisor. He supported me a lot. And very important, he always gave me the opportunity to express my ideas. Even if were not his ideas. Like, for example, he was proposing me one project and I say, I prefer to work in this other line because I think this is also interesting. So I don't forget your project, but I also want to develop my own projects. This is usually like encouraged when you talk to male colleagues, but when you talk to female colleagues, there is like a common point that we were not able to develop of let's say our own ideas so much, or at least as much as our male colleagues. So this is another thing that I suffered, not in the PhD, but after the PhD. In later stages, it was really much harder. And for example, in addition to this, let's say, not promotion of proper ideas, male colleagues usually don't suffer of comments that are not very appropriate. And for example, I can tell you that I had comments about my physical aspect in work environment. So, and I am very hard sometimes. I say, why are you commenting me these kind of things? They are not work related, so please shut up. But you cannot do that always. And also about the maternity comments, I remember one conference, I met one person, a male colleague. It was the first time I met this person, so no reason to ask anything about me unless working issues. And he asked me, "Oh, so why you are not mother yet?" And I say, "Why are you asking me this question? It's really nothing about work. You are not a close friend. We are not in a maternity or gender talk." So, I mean, it was really not the place to ask that question. And that's something very common for women. So these two things, and in addition, for just last point I would like to mention is that it's about authority. So I remember giving a lecture and I was not seen as a professor, but I was seen like, oh, this little girl is giving a talk. She's not so bad talking about gravitational waves. And I don't want to be aggressive or I don't want to be like super serious to be respected. I can be myself. Everyone should be that person. And we don't need to be aggressive in order to have respect and authority by our colleagues. So, and this is something subtle sometimes or very visible other times, but that we should not tolerate.
Thank you for this. Thank you for this, Isa. And it is also my belief that science and everything actually should be gender invariant. Okay, so
Yeah.
I hope that in the future things will improve for you, for everyone actually, so that we can all work towards the shared goal to understand our world
I
better.
Yeah, I am optimistic. I think new generations are supporting everyone more, and this kind of programs and projects is a clear like activity that you are really supporting diversity in general. And I think really new generations are start to think in another way. So I am very optimistic. I am complaining a lot about these things, but I am also very optimistic that this will change in the future.
I understand. You also described maternity, and in the whole process, I couldn't stop myself thinking, how do you balance your life as a researcher with your personal life? And what does a day in your life look like?
Yeah, okay, so it changed a lot. So before being mother, I had a lot of time in work. So I work a lot. Don't believe scientists, we really work a lot. It's a hard job, but it's so fascinating and challenging that you also enjoy a lot. But we are more than work. So before my maternity, I spent a lot of time going out with friends. I love music, so I play in bands, in orchestras, also outside of Spain. I also like to do a lot of activities with children in general because I think they are really super logical and super interesting. And now with the maternity, it has changed a lot because in the university, I have a lot of teaching, so I need to share my time, my working time between research and teaching. But now with the baby, I want to also spend a lot of time with my family. And one very important thing is that at 5 o'clock I say, sorry, I have to leave. Without the child, I can organize my time in a different way. So I had no problem to teach afternoons late because we can organize time in another way. But now, for example, I used to come to the university in the morning, more or less early, not too early, but more or less early. But in the middle of the afternoon, I am done and I prefer to go with my family. But also, I like, as I told you, music. So I am starting playing with a band here, and I am a normal person with a cool job, but also doing normal things like going out with friends in the weekend. And I really try to go out to natural environments. So I live very, very close to the beach. So I love walking along the sea, and try also to disconnect and to meet people. You can do science and be super social. So don't worry about that.
Thank you. So you can tell us that academia can actually accommodate everyone, and it is indeed possible to set boundaries between personal life and professional life. Although, many people consider scientists as overworked people, full with
Yeah.
deadlines coming from everywhere. They lose sleep and so on. But this is the archetype.
Yeah, so this is, I mean, this is not based on imaginary models because it's a question of being a team. So I can give my lectures in the morning because I have other colleagues giving lectures in the afternoon or evening. And this is something we all need to understand, and we need all to be like flexible but trying to accommodate for everyone's particular aspect of life. So I was not teaching in the morning always. Maybe after a few years I can go back and teach in the afternoon. So it's something that we need to do with everyone and try to organize everyone in such a way we can develop our own life stages. And then it's true that we can have this kind of normal life, but like the calls we have are not helping too much. So, for example, I remember this Christmas, I needed to rest because I was really tired, not sleeping too much in the night. But there was a national call once per year, and it's always happening like at the beginning of January. So it doesn't matter if it was my holiday period in principle, I had to take some of the time and dedicate it to filling the call, to prepare the call, and to send the call. So this is something we still need to improve a lot. The organization in the institution should allow everyone to develop the particular life stage, but also the calls by national or international institutions should be adapted to more flexible moments. So, for example, until 2 years ago, or not too more than 2 years ago, a national research call was not taking into account breaks due to maternity or parental leaves in particular, in general, or also, for example, if you have a break because of a long illness. So this call was only taking into account breaks very, very recently. And this is something, it's not about women, it's something that can happen in general, no? That you have a long illness, or that you have to take care of your parents. Even if you don't want to be father, you are son or daughter, so you need to take care of relatives. And these kind of things still need to be included in a more serious way.
Thank you very much. Thank you very much for this. So let me go now to the teaching part, and
Yeah.
I wonder, what would you change about how science is taught or shared, communicated, after all, in order to make it more inclusive and more exciting for girls? We know we have a lack of girls in STEM. So what do you think about that?
Well, I think the problem begins very, very early. And in particular, maths and physics are not taught like discoveries. So when you talk to children, they love to open closed boxes. They love to see what's under a rock and these kind of things. But then when you go to a school, it seems like math and physics is a straight line. There is only one way to do things. The way should be memorized, or there is like only one strategy to solve a problem. And this is not true. So we need to change that. And then one point about science is that it's normal to make mistakes. It's normal to try to solve a problem with one strategy, and maybe this is not the best strategy. Maybe you can solve the problem, but it takes a lot of time, or maybe you cannot even solve the problem. So this is not also said to people and to children in general, that it's normal to make mistakes, it's normal to take several attempts before you success, and it doesn't matter if you are not the very first one always. So again, this like competitive, aggressive way of understanding science is not helping girls, because there are a lot of social pressure for women to be silent, to be caring of the family, and not to be like facing challenges. So one thing, I would lower the level of aggressivity and prize recognition. Like, you don't need to be the first, you just need to have fun. And we need to touch things, make mistakes, work in a collaborative environment. It's better if you have a team of different people with different ideas, because let's check everything and see what's better in this moment or in this problem. And in particular for women, this problem of the make mistakes is very, you have a lot of pressure, no? There are a lot of pressure for women and for girls in particular to be somehow perfect, to have the perfect hair, to have the perfect dress. Don't go to the water because then you need to change the dress and these kind of things. So for women and for girls, I would say science is wonderful. It's about a discovery path. It's not about that you know the recipe and you just follow the recipe. It's more like, okay, you have a lot of ingredients. How do you want to combine or try to combine the ingredients? And let's see what's happening. This is more like science. We may make a lot of mistakes before knowing the perfect way of cooking a pie. And it's okay. It's part of the process. Some of the most important discoveries in science were done with a little of serendipia, meaning you don't know the answer before you start exploring. You just start exploring and then see what's happening. And then, yeah, about girls, I would say something very, very mathematician. If you don't have an argument that makes you not able to do something, just try. Just try. I remember this TV series, Lost, and there is a sentence: don't tell me what I am not able to do. If you don't have an argument, let me try. And if there is no a theorem saying this is not possible, then there is still room to think about a potential solution. And when you let people, let children, and let girls to explore, the experience is so fun and so wonderful that at least you have to try once.
Thank you. And let me add something in the question. Do you believe that communicating frontier science, like the research for gravitational waves, to high schoolers or maybe even younger students, could it help them perhaps join science more easily? Could it help girls join science, give them incentive to do that?
Yeah, for sure, because when you think about the normal contents you have in school and high school, it may seem like a little boring, no? Why I am studying so much algebra and letters and numbers if this is not going to a point? But then when you show the young people that all these mathematical tools or physics theorems and laws are very important because with them we can understand and we can discover new things, then this is very exciting. And also, I think it's very nice to give them like close examples. No, they all have these mobiles and these machines, but they don't know that actually there are a lot of maths and physics behind. So when you say, okay, this general relativity, this gravity theories is helping us to explain what is the motion of Mercury. Very nice, no? I can see Mercury in the sky. But it's also helping you to give in the localization of a person in the mobile, with the mobile. And this is due because of general relativity corrections. And they are like, oh, really? So I have gravity in my phone? I say, well, somehow the understanding of gravity is included in your phone, so you are not lost in the middle of a forest. Oh, okay, this is something I can touch. And you can do analogies. Obviously, it's not like the full theory, but you can give analogies and you can talk about fascinating things that can be reached when you understand the basic science is behind, no? And it's also about fascination and it's also about getting a cool moment. I really enjoy math, and I think there are a lot of like wonderful relations, no? For example, if you discover that, I don't know, pi can be obtained doing some geometrical procedure. So let's try it. Let's try to make this geometrical procedure and see if I am also able to get this number or why I get this number. And this is something is not showed sometimes, also because you need to study hard. As I mentioned previously, I work very hard, so science is not for free. You need to work hard, but you don't need to think it's just boring and it's not used afterwards, all the science that you know. So I think that going to the high school and showing and communicating these wonderful things we are discovering and how this can be applied in a normal life is something that can motivate new generations, because actually children are the first scientists we have, and then we may change sometimes, but if we keep the motivation and the discovery moment to children and young people, I think we will get more people supporting us.
So maybe in this way we may be able to, let's say, prepare the next generation of researchers, right?
Yeah, yeah.
S- So I would like to ask you, what are some of the big questions in physics and science overall today that girls growing up now might help solve in the future? What do you think?
Well, I will mention a few ones coming from astrophysics and particle physics, but I am pretty sure any area of research you go, you will have like new things. For example, about materials, I don't know too much about materials, but I know that there are people developing new materials with new properties. You never know what's going to happen in research and in science, no? But in particular, in gravity, it's very funny because if you read history about Newton's moment and theories, they thought, okay, with these laws, we can understand the universe because we understand things in Earth, but we also understand movement of planets. So everything was like more or less ready. And then suddenly, a lot of experiments were not able to explain anything. I mean, the laws were not able to explain anything of a few experiments. And suddenly we were like, okay, we don't understand too many things. Now we are more or less in that way, like we have wonderful laws like general relativity that explains all the movements we see, also the gravitational waves that we are detecting are in accordance with the theory we have. But there are other things we have really no idea. So, for example, even gravity itself, the theory has some problems like black holes. There are some things called singularities that we think there should not be the final answer. And we are like really open to a lot of ways of solving that. And also we have gravity and we have particle physics theories, but we don't know how to mix them. And this quantum gravity theory is actually super open. There are some ideas, but we don't know what's the good one, or even if one of them is good or not. And then about the content of the universe, it's also a big mess because everything we see or we can detect and interact with us is just a very small fraction of the universe. There is something called dark matter we don't understand, and there is also a even bigger thing called dark energy that we don't understand. There are new experiments measuring how the acceleration of the universe behaves that are giving us maybe new data to try to understand that. But it would be really cool to see young people in a few decades telling me about, hey Isa, I know that matter is now formed by this kind of particles with this kind of interactions. So if you think that in science and in gravity we have everything done, it's very, very far from reality. We know a little, but we know that there are like big questions about quantum gravity, dark matter, dark energy, singularities we have no idea yet, and also the unknowns. And I am really looking forward to detect a gravitational wave signal that I cannot explain with my current models. And we need to really develop completely new ideas and completely new objects. So this is exciting, isn't it?
It is indeed. It is indeed. So, Isa, I would like to conclude this discussion by asking you, if you could give only one advice to a teenage lady, what would that be?
I would say don't be afraid to make mistakes. Mistakes are wonderful.
Thank you very much. I think this says it all. So, with that, I would like to
And
thank
by the way,
you.
I have done a lot
Yes.
of mistakes. I have done a lot of mistakes and I have learned a lot from them. So don't really be afraid to make mistakes.
With that, Isa, I would like to thank you very much for this wonderful opportunity you gave me, and we're looking forward to sharing all these beautiful insights with the girls around Europe and beyond. Thank you very much.
Thank you very much, Manolis. Thank you for your time and the opportunity to give some comments to young people.
Goodbye.
Bye.